Hi there. Now we're going to connect light to the hydrogen atom. You have already learned that there are shells of electrons and that we count from the inside out. And we have also discussed how the one closest to the closest to the nucleus is considered low energy, and the one farthest from the nucleus is considered higher energy. We have also discussed how to move up in shells. So for example, to go from shell 1 to shell 5 is going to require energy. And another way of saying require energy is that it's absorption. This is also called excitation. And we excite an electron to a higher energy level. So it would be moving from here to here, for example. When an electron falls back down, so for example, let's say it goes from shell 5, which it's in, down to shell 2 or something. So from 5 down to 2, that way, jumping back down, it's going to release energy. And this is known as emission. And in this case, it's as light. When it absorbs energy, it can absorb it as light. It can absorb it in other different forms. Light is one of the possibilities. When it releases energy, it always releases it as light, but that light can vary based on how big the jump is. Bigger jumps have more energy associated with them, and that changes the wavelength and frequency of light. So we need to know a little bit of something about light in general. So for light, it's a wave. The difference between two crests of a wave is known as the wavelength. This wave has a higher wavelength than the wave below it does. This would be a shorter wavelength. One of the notations that's used for wavelength frequency is frequently is the Greek letter lambda, which is an upside down Y, and that means wavelength. So the top wave is higher wavelength, the bottom one's a shorter wavelength, but this top wave is also lower frequency, fewer waves per second, and this wave is higher frequency because it has more waves per second. So we have a trade-off here that as the wavelength's longer, the frequency gets lower, and vice versa. We have an inverse relationship. Perhaps you've learned something about the electromagnetic spectrum before. This includes all kinds of waves. Like down here in the really low energy levels, the low frequency, we might have something like radio waves, which are part of the electromagnetic spectrum. If it has a low frequency, it's also going to have a long wavelength. High frequency waves, we might have something like gamma rays. Super high energy, super high frequency. Below gamma rays, we have X-rays, we have UV, then we have the visible spectrum. On the other side of the visible spectrum, we have infrared, and then we have microwaves, and then we have radio waves. Cell waves are somewhere in the micro and radio range. I noted down here that as we go from here to here, we have increasing frequency. And we also have increasing energy. The energy associated with gamma waves is much higher than that associated with radio waves. If we go the other direction, we're in increasing wavelength. There's only a small part of this that shows up as something that your eye can see, and that's in the middle here, what we call the visible spectrum. I'm sure you know that light can form a bunch of colors. If we split up white light, we get this range, this full rainbow. And within this rainbow, we have different wavelengths and energies associated with it. As I go this way from red, orange, yellow, green, blue, violet, we have increasing frequency, increasing energy, just like above. If we get outside the visible spectrum, above Violet in energy is what's known as ultraviolet, literally meaning above violet. These energy waves are more damaging to your skin, I'm sure you know, than visible light is. If we go outside the spectrum the other way, we have infrared, which you can't see, but you can buy goggles that can see. The wavelength of light that this spectrum includes 4 times 10 to the negative 7th meters on this end, 7 times 10 to the negative 7th meters on that end, or it's also called 400 nanometers to 700 nanometers. So again, wavelength increases as we go that way. You definitely need to know which end of the spectrum is high energy, which end of the spectrum is low energy. So if you just go in order from red to blue, or red to violet, will be increasing energy, increasing frequency, and wavelength is inverse to that.